Hi, welcome to what's the third video in my series of trig graphs. This one here is going to look at graphs that move left or right. Previous knowledge should be being aware of the difference between the amplitude and number of waves in a graph already. So, as usual, I'm going to start with the very basic y equals sin x graph. So things you need to be aware of this one is that your sin x graph starts at 0, finishes at 360. The graphs today, I'm going to alter the equation and you're going to see the graph shift left or right. And what you have to decide is how much it's shifted. Has it shifted left or right? And what does that mean for what we have in our bracket? So let's have a look. So on top of the basic sine graph, I have drawn in this blue one using the Desmos calculator. So in class, obviously, I would be doing this and you'd be able to see it happening live. But so here, we have y equals sine x minus 30 in the bracket. Now, what I want you to do is look at the red graph, compare it to the blue graph, and see what's happened. I'm sure you can all see that it's definitely moved right. Yeah? It's moved that way, so it's moved right. How much has it moved? So what you have to do is you have to compare this graph to where the original sine graph should be. Now, they're not always going to be drawn together though. Now, looking at it, it should have started at 0. This one now starts at 30. It should have had a wee root here at 180, but it's now at 210. It should have finished at 360, but it's probably going to finish at 390 over there. So we can look at all these well-known points of intersection of the graph and notice they've all moved 30. So it's moved right by 30 degrees. Now when it's moved right, it's got a negative in the bracket. Now you would think moving to in the right, you're going into the positive direction of your coordinate system on your x-axis, but it's got a minus in there. Now the reason that is, if you solve x minus 30 equals to 0, you get x equals 30, which is where this graph starts. Let's have a look at another one. So again, I've got the red graph as your y equals sine x. The second graph is sine bracket x plus 60. Now the green one, can you all see that the green one has moved left this time? Okay, so it's moved left. So it's moved into the negative direction. If you're plotting coordinates, you're going to the negative direction and it's got a plus in the bracket up here. So if it moves left and goes negative, you put a plus in the bracket. And the reason that is if you were to solve x plus 60 equal to 0 again, that would give you x equals negative 60, which is probably where this graph would then cut the x-axis if I had drawn the full thing in, but I haven't. So what I need you to take from this is that if it's moved in the negative direction, we put a plus in the bracket. And if it's moved in the positive direction, you put a negative in the bracket. So this kind of bit here is the opposite of what you think. Right, so the sign in here is the opposite of what your instincts are telling you, and that's the trick. Now to decide how far it should have moved, I'd probably look at this one, this point here. This should be 180, but that's 120. That's moved 60 that way. This should have been 360, but it's actually at 300, so it's moved 60, and that's how you decide the number that goes in the bracket. So this is probably the notes section. If you are taking this as an actual lesson, I would pause and copy this bit down here, okay? So this is what the formulas are going to look like. It's either sine or cos in front of a bracket, and it could be plus or minus, and we call this number C. So C is called the phase angle. It's how much it's moved left or right. And then just a little note to kind of clarify what I'd said in the previous slide. If it says x minus 30 in the bracket, it's moved 30 in the positive direction, which means 30 right, and that means your graph starts at x equals 30. If it says x plus 30, it means it's moved the opposite of plus. It's moved 30 to the negative direction, which is left, and it starts at negative 30 instead, okay? So here are some examples for you to copy down. Now in an exam, it will tell you whether it's a sine or a cos graph, but I will show you a couple where it could be either. It depends how you look at it, glass half empty, half full type of thing. So for the first one, I've drawn on that blue dotted line just so we can compare it. So what we're looking for is the equation of this black line, okay? Now, it is a sine graph, which I hadn't put in, so apologies for that. It was a sine graph, and it should start at 0, but it clearly starts at 45, so it's moved 45 in the positive direction, so you put negative in there, alright? So that's what that graph is there. Okay, so it's moved 45 in the positive direction, you put minus 45 in there. Okay, so this example doesn't have the original graph drawn there for you, but remember we can always do the original one. We've been told this is a cost graph, so I always encourage pupils to put a little sketch here of the cost graph first of all. Now your cost graph, this point here should have been 90, or this point here should have been 270. That's what I'm going to focus on here on this diagram and decide how much it's moved. It's a cost graph that's clearly moved left, right? It's clearly gone in that direction. But how much has it moved left? That's what we need to work out. So you're looking for the difference between 90 and 35. So that should be 90, but it's 35. That makes a difference of 55. So it's moved 55 degrees left. So if it's gone in the negative direction, you put a plus in the bracket and a 55. And that's how I've got the equation. My third example. Now I'm looking at it straight off seeing a sine graph, but if I was to extend the diagram a wee bit, can you see how that could potentially look like a cost graph as well? So I'm going to treat it as a sine graph first of all. So if it's a sine graph, your sine graph, this point here should be 180, but on my graph it's 140. That's a difference of 40. So it's a sine graph that's moved 40 in that direction. So if it's gone negative 40, you put plus 40 in the bracket. Now looking at it from a different perspective, if I look at it as a cost graph, the cost graph, this here should have been 90. Now this is a cost graph I'm looking at here that I'm tracing with a red pen. Hope that makes it more visual for you. So it looks like a cost graph that's gone right. So there's a mistake there on my slide as well. That should say right. That's a copy and paste error. So if it was a cost graph that moved right, that number should be 90, but they've got 140. That's a difference of 50. So it's gone 50 in the positive direction. So 50 positive becomes negative 50 in your equation. Now, as I said, I hope this isn't throwing you asking for two equations. Normally, you will be told this is a sine graph. What is the value of A in the bracket, or B or C? Okay, they'll tell you whether to treat it as a sine or a cos. Okay, my last example, I'm wanting you to look at it as a cost graph. So I'm just going to trace the cost graph here. So there is the cost graph in red. Now your basic cost graph, just to remind you of the picture, this should be 90. Or this one should be 270, whichever you think's easier to use. So it's clearly moved in that direction. It's moved to the right. So it's moved positive. So we know it's going to be a negative in the bracket. If it's moved positive, you put in the opposite, you put in a negative. How much has it moved? So you can compare any of these three roots to the 90 or the 180 or the 270 that they should be at. 90 to 107 is a difference of 17. 180 to 198 is a difference of 17. 270 compared to 287 is a difference of 17. So it's moved 17. So it's negative 17 that goes in the bracket. Now, one thing that I've not done in any other examples is this one also includes an amplitude. The highest number it goes to is 3. So it's a 3 cost bracket x minus 17. All my other ones have all always gone from 1 to minus 1, but they can combine the two parts here. Secondly, if I want to look at it as a cost graph, if I want to look at it as a sine graph, your basic sine graph looks like that. and this is 180 in the middle. Okay, so as a sine graph, I'm thinking that this is a sine graph here that I'm now tracing in blue. So we're now looking at that as a sine graph that's moved that way. So it's a sine graph that's moved left. So because it's moved in the negative direction, we put a plus in the bracket. The highest number it goes to is 3, so a 3 in front. And then we decide how far is it moved. So that should be 180, but it's 107. So what is the difference from 107 up to 180? That's a difference of 73. So because it's moved 73 left, you've got a plus 73 in the bracket. Now that's all my examples. I haven't shown sketching in this video because I don't think they'd ask you to sketch a graph with a phase angle at National 5, and I don't want to add too much to it right now. So I hope you've understood them, give them a wee go, and good luck.